to this seminar, to the Ronin Institute seminar. Before to start to present Candace, I wish to give us an intro for the seminar. If you are unfamiliar with the Ronin Institute for Independent Scholarship, it is an institute that is dedicated to supporting and facilitating the work of an international community of researchers. Together, we are building and maintaining a diverse, equitable, inclusive, caring, and human model for knowledge production and communities. If you have any questions during the seminar, please do not write them in the chat box according Candace's preference, but please save them for the end of the presentation when she will be taking questions. Also note that this seminar is being recorded and we will have the seminar posted on our YouTube channel, and the recording will stop when the presentation will be finished, and so before the question and answer. So how to present Candace? Candace's research interests are diverse, with a common thread of healing, adaptation, and sustainability, whether it be human-created or nature-inspired. She completed a certification in acupuncture and has organized community research project on a treatment named Sun Fu and related to boosting immunity using tropical herbs on acupuncture point. Following a passion for plants, she is working on an illustrated plant medicine book, Ancient Plants of Napa Rui, to help the people of Napa Rui grow their native medicine and food plants once again and help them replant the forests. And she's continuing the ongoing research of a 5,000-year timeline between punctuating climate shifts, droughts and floods, and cosmic events, comets and supernova, and their reflection on cultural adaptation. So please, Candace, the floor is yours.
Thank you. I'm going to switch my screen now for everybody. And we have a couple of videos in here that hopefully will give you some good sound. Thank you for coming today. It's always difficult to set this presentation up because there's so much to talk about. And I know you have lots of questions. So I will do my very best to go through efficiently and present some of the work, which is mainly today, I'm going to talk to you about the trees. So my work, coring the crater lakes on Easter Island, started in 2002. And this has been a life work for me. So we'll begin. We're ready. So first off is Urana means hello. And so when you go to any distant land, you learn the language. And so I've learned quite a lot about the language of the trees and the people. Urana means hello and goodbye. So today is about stories and theories. And so I put this clause in, nothing's ever absolute. Someone's going to come along after me and make changes, and just as someone's come before me, and I've done the work. So first off, I want to give gratitude to John Flenley and Scottsburg, who started the work of coring and looking at fossil pollen, who discovered that there was actually a giant palm on the island. So even though all we know what we know with science, there's a common story about Easter Island is about the islanders cutting down their trees to move their statues we call moe, and it ended their cultural and collapsed their environment. However, with new information, we have a new story. So I wanted to test a simple question. What happened to the trees? As simple as I thought it would be. So what can I tell you about Rapa Nui that you don't know yet? I want to show you some of the beauty of the island. I want to show you about these trees that breathe like animals, show you the crater lake in the South Pacific, and tell you a little bit about climate change, and then my story that came along with that. So some people have this little cartoon as their belief system about Easter Island. There's quite a lot of stories and theories. But I thought this was a nice little cartoon. Easter Island has lots of stories. So first off, I want to start with beauty. I want to show you some pictures of the island if you haven't had a chance to be there. Okay, so the name of the island, we call it Easter Island, was given in 1722 by Jacob Roggeveen. The Rapa Nui people, or Polynesian, they call it Rapa Nui. And before that, the ancient name was Te Pito o Te Hanua. To the people of the island, this was the navel of the world. So this is what we see today. We see the remnants of a culture past. So in this picture is a dynamic view. Poiki is the name of the volcano over on the right, 3 million years old. Rano Kao straight ahead with the cliff cut that you can see there where the moai were lifted up from the inside and lowered down with huge ropes and trees, and then the moai themselves laid to rest. So this is Rawaku from another view. This is where all the moai were carved from. And you can see the cliff cut where all the moai were lowered. And it's quite a feat in itself, although my work was on nature, not on the moai. So I'll tell you a little bit about it. Another view from the North Shore, Anakena, the story of the arrival of the king. All of this comes in from this place. And a long shot view looking from the South American coast. This is the first arrival that you get to Rano Kao, which is the crater lake that I worked on, and the remnants Moto Iti, Moto Nui of the volcano itself. So that formed 1 million years ago. And what you see here is the kirikiri, or the knife blade cut. And what you should know is that it's slowly eroding. One day will be breached and gone forever. The South American swell, this is the first land that it hits as it's moving north. And more views, North Shore, landscape. This is the last surface water. There is no surface water really, it's collecting in these crater lakes. But there is rain, and it does run down this old collapsed lava tube. And when you look around the island, you see lava everywhere. And so there's not a stone that hasn't been touched, turned, or moved around. As an archaeologist, you can look around and you can see that bright green area up above is an old plaza, nitrogen left behind. So you start looking at landscape and looking for changes. You can see there all the lava, and sticking up in some places are still the old markers we call pipi horekos. They're standing standing stones like cairns. And then if you look on the left side, that's an old fish habitat quarry. And then another pipi horeko there. And then the moai. And then the stories of coming later and putting top knots on the moai. They have a long progression of years of change. Everything that you see standing up today has been resurrected. This is Tongariki looking at the moai quarry, the largest one. It was taken down. It was a little closer to the coast and washed out with a tsunami, which is a common occurrence there. But remember, everything that we see standing has been rebuilt. And the moai all are standing and looking inward, except for 1 or 2 platforms where they're looking out to coast. So there's a long story about that reasoning to Thor Heyerdahl found what he's called the Inca Wall. So besides being magnificent engineers and builders, there's relation more to the ancestors of the people and why they built these stones the way they did. So one of the finds on the left-hand side you see there is a female moai. So all we see standing today in pictures are male, but before there were the men, there were the female moai. And the one on the right, these stones were used, recycled in the ahus. And the body of that statue on the right was taken by Thor Heyerdahl to Norway, kept there for many, many years. And just recently, the head of this statue was found, and you can see this is the female moai, and repatriated back to the island and put back together. Things that are left behind are petroglyphs like the Maki Maki, the bird cult, and the Rango Rango script, mostly on wood. This one is on stone. So I'm just showing you some of the cultural stories that you have probably heard. And the moai laid down and covered, a lot like we see in the desert Southwest. Old plazas, chicken houses, etchings of octopus and water creatures. Vai means water, vai hu, and other 300 place names for water all over the island. Lots of culture stories. So my work was on the natural history. Let me begin with explaining about the island. So before I can even begin my work on trying to figure out time and climate history, have to look at the dynamics of Earth. So Easter Island is located, considered one of the most remote land masses that's inhabited on this planet. So it was very difficult to get there in the past, but when things are not in COVID, there's a 747 that lands every day with 350 people that come to see this island. So that's where it's located. In its relationship, you'd fly to Santiago and across. And the island itself is 14 miles long by about 7 miles wide, has over 70 volcanic cones. So this is a volcanic landscape. Over on the far right, Poiki was the first volcano that formed 3 million years ago. And then the lower left is the crater Lake Rano Kao, left of the remnant of another volcano 1 million years ago. And then they got joined together with the area you see, Rano Arroy, which is another crater lake. And these are the only 3 holdings of water on the island. And when that one blew up at Teravaca, it joined them all together to form this island. So the South Pacific Gyre, you can see Easter Island is kind of in a doldrum area. Everything's acting around it. So there wasn't a lot of sea surface temperatures and ships that would pass through, but it's a really dynamic place. So you can see nearby Chile, volcano explosions, affects Easter Island. And when you look surface, what's happening in the tectonic plates, there's earthquakes quite often happening around the island itself. And looking at this diagram up on the right, you can see how all the plates merge, the East Pacific Rise and the Easter Seamount Chain. And I'm setting you up to explain some of the theories about what happened, why all the moai are lying down, and various things that have happened on the island. So climate and weather, rainfall, there's quite a lot of rainfall. There's 38 inches of it a year. The westerlies come in 4 months of the year. Trade winds come and hit that southern area of Rano Kao 6 months of the year, and solar radiation is really intense. So when Carl Scottsberg, the naturalist, landed on the island 100 years ago, he said there's no reason why there shouldn't be a forest here, because there's all of this natural sun and rain. So there must have been something else happening. So taking more modern day rainfall statistics here, this is data collected. So there are cycles that repeat. So every 17 to 22 years, there's very wet events, which includes 200 centimeters or more. And then there's droughts where there's less than 50 centimeters every 7 to 10 years. And this is what the landscape looks like. So what the trees you see there now have been brought in modern days. Eucalypt has been planted and there's fruit trees now, but essentially it's all the volcanic cones that you can see there. So let me give you a short on the people, since the story set up that the people, the islanders arrived, cut all their forests down, and then collapsed their own culture. I want to introduce you to one of the stories of what actually happened to the people on the island. So whalers moved into the South Pacific in the 1700s, and by the 18th century, both Britain and America were part of this slave stealing from the islands to bring to the guano mines on the coast of Chile and Peru. And so there's stories that are well known but not well accepted. 1862 was the big cultural collapse, in the sense that 1,500 people were kidnapped from the island by 8 Peruvian slave ships, bringing them to the mines. And of course, the last keepers of all of the oral knowledge, the last king, were part of this slave stealing. And in 1888, when Chile annexed the island, there were 111 people left alive. So at this time of 1862, the thought was there was 4,000 people on the island. And so the first missionaries came and started to put the stories together. And the anthropologists came over to measure the culture, more or less, and some of the things we've left behind, or we find that are left behind. The 111 people that were still found living on the island after disease and various things, the slave marauding, were put into a leper colony, and it's still known as town today. The rest of the island became a national park. But the culture of the people still, even like all the stories we hear of other culture decimations, managed to keep some of their belief systems that now are being brought back. So Rapa Nui gods, like other Polynesian gods, could be incarnated as objects or animals. And so the ocean, the turtles, the seals, the trees, all were animated by the spirits in the culture of Rapa Nui. And in particular, the trees, since I talk about trees, the name Toramiro was given to a tree that was planted next to an ahu, or a platform, as sacred. So there is a tree, the Sephora Toramiro, that has been alive for the last 15,000 years across my timeline, and is probably one of the most sacred trees to the Rapa Nui people. But just know that a name can be interchanged. The Toramiro is both representative of the tree, but also to a sacred tree. And it could be a palm tree that was planted, but it became a Toramiro. And these are modern day sculptures that were built to represent the different areas that were taken care of by the people. So it's a cultural system. They were the caretakers of the fish, or the caretakers of the trees, or the caretakers of the water. And so they all worked together. And it was thought that, taboos were given if a fish migration was low one year, then the caretakers would give a guidance order, they called a tapu or a taboo, to help regenerate. And so the female moai was also part of this matrilineal society, which still exists today. And some of the moai stories, Huri a Uringa is the only moai on the island. He's now been stood back up again, but he has 2 sets of hands instead of just one, like most of them. And this is a photograph of my own during equinox, where the sunlight, he is faced directly towards the rising sun on both equinoxes, which I believe the 2 hands mark both fall and spring. So the moai, not only were they representative of their ancestors, they were also timekeepers on the island, looking up to the stars. And with that, there are lots of sculptures left behind, like this one, the Matamia, the red eye Mars, the bringer of bad things, perhaps, in their stories, following along these cycles, these repeating cycles. And a lot of the things that we know about the culture language, because it was all oral tradition, have been found only through these written tablets. And so in Oceania, the Rongo Rongo is the only written language that has been found. And these tablets were, first off, what trees there were no trees. What trees were these pieces of wood taken from was one of the questions. And that Sephora Toramiro was found to be on some of the tablets, but most of them come from the Pacific rosewood known as makoi, which is a sacred tree in Polynesia. So the interesting thing about these Rongorongo tablets, you can see the petroglyphs or the pictographs down below, the characters that are printed on these wooden tablets. They are known to be sacred tablets of chants or songs or stories, and they're read left to right, then turned over and read left to right, then turned over and read left. So every other line is upside down, because there is a interaction with this wood tablet as they're reading and moving along with this. So at one time there were hundreds of them kept in the family caves. Now there's a known 25 to exist, and none of them are on the island. They've all been taken to museums. Some of the writings relate to this one particular Pao, which is the bright crimson red star. And these characters all together tell a story that the ripe star is returning. So they've told about their lives and adventures and their sightings. And as you know, the Polynesians were great storytellers and navigators. And these are the people today reclaiming their culture and their strength. And so this is Tapati, which just ended. It's a 2-week festival in the spring. And these, my friends, are very strong people. So I wanted to tell you a little bit about their culture before I get into the natural history. So the giant palm forest is the question. So once Thor Heyerdahl came in with his large expedition in 1958, brought all the scientists, they dug some sediment out of Rano Kao and found a palm pollen. But that story died, other than there was no completion of that pollen record until John Flinley from New Zealand, was my mentor, came in the 1980s and started coring the sediments in the lakes. Did we really know that there was a giant palm forest? Up till then, the land was considered barren and no one really knew how the moai moved around. So this palm is identified as a Jubea chiliensis. That's the giant palm in Chile. So the variant on Easter Island, of course, is different. So they named that one Pascalococos, the Easter cocoa. But they're similar. So you can see how large they are. They're 20 to 30 meters tall, 2 to 3 meters diameter. And through the pollen analysis, we're able now to know that there were lots of diversity of trees on the island, but these were the dominant trees. So the Jubaia, the Pascalococos, inside each one of these trees is 100 gallons or 400 liters of sugar water, which likened to sugarcane, about 18% water. And they're pretty tolerant of everything except for cold. They can't go dormant for a long time. But the trees are monocots, which means that each one of them has their own unique mana, as we call it on the island, their essence of life. And so it's incorrect to call them the cocos because they don't have cocos, they have coquitos. So these are the fruit pods, and these are the trees at the Natural History Museum in Santiago, which are alive and standing now. And taking a look at the bark of the tree, you can see its growth patterns, but when you look a little deeper, you can see that even though the bark is strong, it's full of vascular water and spongy construction. So they make terrible rollers. So the whole idea about cutting the trees and using them as rollers for these 20-ton moai didn't make any sense once you know these trees. So the question is then, if there were millions of trees on this island, what really happened to them. And so John Flindley started to do equations from Meath and Bork archaeologists that went out and took these meter readings on certain sections of the island to try to determine how many trees were there. So they calculated that there was 38 palms per 100 meters, or 1,400 trees per hectare. So 70% of the island was covered with these giant palm trees. And you do more calculations about that area, you end up with 16.24 million giant palm trees before they were cleared, or they died, or cut, right? I'm going to leave that still up in the air. So if you take that many trees and you ask, how fast could they possibly cut them down? And John Flindley further went in to calculate with the pollen when charcoal was spotted in the cores, just as I did. You look for changes like fire, you'll have charcoal signatures. So he came up with the idea that it took 800 years to clear these 16 million trees. They would have had to cut 20,000 of them a year and 55 of them a day to keep up, to completely take all of the trees off the island over 800-year period of time. So they would have begun 800 AD and ended around 1550. That's what his work uncovered. And so that's where I started from. So there's at least one tablet that has left behind a pictograph of the tree. There is no known name left in the Rapa Nui people for the ancient trees, which means they were gone long before the memory. So we have inscription, we know they existed, and we have old cocoa nuts in some of the burials. But you should know about these palm trees. They're monocotyledons, which means they're different from any other tree on this planet. They are the world's longest lived trees because the stem cells in these monocots remain active for their entire life. And these trees are considered self-regulated organisms. A palm tree behaves in a sense more like an organism with a unitary or an animal-like construction rather than plant-like or modular. So the idea is, once you think about 16 million of these giant palm trees that have their own unique DNA and regulate and self-regulate themselves as an organism, imagine the breathing life and the essence of this island. So from an evolutionary perspective, all groups of these organisms are genetically unique as independent lineages. So each palm can survive in its unique way, adapting to habitats, meaning drought, rain. It wasn't about water, it's about temperature, freezing temperatures. They can't go dormant for long periods of time. So we do know by things that have been left behind that there was a massive amount of soil erosion due to the loss of the trees. So at first people thought they were just heads, until this is a picture over on the right from National Geographic of the actual uncovering of the entire statues that were not buried, but covered up by soil erosion. And the story over on the left, the photo or the picture there, is from National Geographic as well, where the old stories from the islanders about the moai being moved, not drug, on trees by standing up and walking to their ahu, is an old folk story that now people are starting to listen to. And so this one depicts the movement of the moai upright now and being walked back and forth using ropes to teeter them to their places. But I challenge you still, just know that I don't work on the moai, but trying to make that association between the trees and the moai. These moai are, 20 to 40 feet tall, weighing 20 tons, that were moved 14 miles across volcanic landscape. So Rano Kao, let's get to the lake. So this is where I do my work, right? So it was a million-year-old volcano formed, and the crater is what's left behind. So looking from the top down, you can see there's a floating mat, and walking down and onto that mat is the quagmire of this. Everything has to be hand carried in, and there's always the worry about falling into the lake and losing your gear, because the water itself is full of tannins. So I can set a sachet disc down in 6 inches, it disappears. So it's all about decomposing plants. All that water is collected purely by rainfall. So it made a really nice science experiment. So the plants are mostly totora, sedges, and the polygonum, which form the mat. And this is what it's like to walk down the 600 feet down the slope of the crater. And we arrive. This is standing on a floating mat. It may look like solid ground to you, but that floating mat is 2 to 4 meters thick. And lots of curious things happen, like dying patches and floating patches that are turning over, still unknown. So this is quite mossy, and if you stick a hole in, it begins to percolate water up. So it's quite an interesting place to work. And it's also a good reflection of changing rainfall patterns on the island. So you can see these are all the years that I've worked there: 2002, 2005, 8, and 14, how one year with drought, it can be brown, and then other years really green. So I'm using that lake to test evaporation of rain and rainfall patterns as well, modern days. But what I wanted to know, I wanted to core as deep as I possibly could, to find out as long in the past these patterns. So coring the lake is quite an adventure, carrying all of the equipment in, and knowing that below that floating mat is 12.5 meters of water. And then you finally get to the sediment beneath that. And we do our best to try to get to the center of the lake. So here's some of the coring points, trying to represent best we can. And so this picture is actually a moving video when in 2005, which is the big core that I took for most of this work. I joined the Stanford team and they joined me. This is their work. They were coring the porites. So ice cores, sediment cores, coral cores are a lot of our climate history coming from that. So they were taking coral cores to uncover sea surface temperatures, while I was coring the crater lake to find out about rainfall patterns and climate history. So moving from the cores, the coral, now this is some clips from our work on the lake. So the elder man that you see there on the left is John Flinley. He passed away a few years ago. John gave me his blessing to follow his work, and I feel so honored that he was there for our coring. So what you saw there was the pipe that had to be sent down into the column 12.5 meters down to make sure that our cores were straight. Although that looks like we're standing on rough ground, that is actually a floating mat that was quite dry. And here's what the cores look like, 1 meter at a time, coming out the sediment. So maxing out hand core is about 21 meters. So a total, I have 9 meters of core of sediment with 12.5 meters of water. That was as deep as I could possibly go. But that totaled 15,000 years of information. So this is how we get the information. I took a sample every 10 centimeters and tested fossil pollen and climate change through the oxygen isotopes. So some of the results are the Jubaia, which is the giant Chilean wine palm. was discovered, and then 4 new palms that were not known to exist on the island. So these are still yet to be identified, but there are 5 palms, one of them at least the giant palm, and 17 tree species that I uncovered. So the island was full of diverse trees and plants. And you can see this is a pollen diagram. At the very bottom is 15,000 years to the top surface, 1,000 years. And you can see the fluctuation of pollen over time, just a visual for you. And then the rest of the trees. So the Triumpheta itself is a cold weather tree. So it's very abundant in the early 15,000 to 12,000 years ago during the last glacial maximum. So it makes sense that that tree was most abundant. And then the palm trees came in when it got warmer. Some of the interesting, curious things uncovered was the aquatic plants. So you see that red circle over on the right, the polygonum, the plant that created the floating mat on the lake, popped in about 3,500 years ago. So this is a curious anomaly, as well as the circle that you see there in the all pollen is grass pollen. Grass pollen, I measured both the native grasses and the foreign grasses, and you can see both of them expanded at 4,000 years ago. So again, another curious question is, usually in archaeology, when we find grass pollen, it's usually because it's brought in by the feet of people. And so here's that same but blown up grass and fern with those same questions. What really happened during this time period, 3,500 years ago? Here's the origins of all the plants I uncovered. There's 40 extinct plants, and now there's a lot more, but pre-human is what I was looking for, and here's where they all came from. And that polygonum that formed that mat is a very special medicine plant. So polygonum grows horizontal, interlocks its roots, and then around 3,500 years ago, the lake was completely dry. And when rain started to come back again, the pressure of the water popped the mats off the surface, and they became the floating mat. So more, I'm working on this plant medicine book, and here's some of those plants that I follow through. Let me speed up a little bit here to get to some of the results for you. Curious things around that 3,500 year mark too was a mite that was found, a conifer bladder, various things that give us indications. If it wasn't 3,500 years ago, would be related to human use. So that's another thing to follow through. What happened 3,500 years ago? And into the climate cycles now. Sorry, I'm going to just pass through that little video. Using aquatic cellulose from the sediments, I was able to compare the ratio of O18 and O16 to find out what really happened from a climate perspective, asking the question, did climate change have anything to do with the loss of the trees? So this is the big diagram. I'm going to stay here for a minute or two to talk about, but these are the results in the timeline. So if you look at the bottom, that's the bottom of the core. So this is a vertical profile. And so the bottom is 15,000 years ago, and you can see the movement. Left is really cold and right is really hot. The timeline is over on the far right. It's in BP, or before present time. And you can see the first timeline is the last glacial maximum, the younger driest, and those squiggles just coming out of really cold events to about 9,200 years ago, where it was really hot. And then that timeline till today has been progressively going into a cooler, wetter environment. Meanwhile, the climate cycles have been punctuated with very hot events. So the average between the cold events You can see these punctuated moments that go to the left is 637 years, and the punctuated moments that go to the right are the hot events. They're every 719 years. And the important part, we go back, that blue arrow is the mat, the floating mat. The last 1,000 years is kept in that floating mat, and that's where most people are most curious. After several coring events, I finally have uncovered a nice detailed profile that actually shows a big event, the one that cycles every 637 years, to have begun at 390 AD and peaked in 1455 and ceased in 1505. So it lasted 115 years, and it was a really cold event, one of the coldest in the record. And you can see how things followed through. But remember that event, it was a very important event that made big change with the trees. The palm pollen began to diminish and fade away after 1456, and the moai ceased to be built around 1500. So I'm going to make my way through to the end. I want to leave questions. This is modern day rainfall data, and the rainfall here in these weather stations showing a little decrease, but solar is increasing. And more photographs to show you that the lake is evaporating water. So there's a watermark on that Totora sedge. And another finding is that this kirikiri has been breached. So if you look at the bottom right, in 2008, when I left the island, there was a break happening right above the water level of Rano Kao. So if that finishes, we'll lose that lake in the near future. And some of the last current findings is also the archaeology at Avaranga Uka. I will show you, this is the collapsed volcanic tube. It runs from Teravaka, you see in the middle of the island. Rano Arroy is a little marsh, and the water trickles down this volcanic tube, and it is been uncovered by the German Archaeological Institute. Sorry, that was another just drone flyover. To show that the top at Rano Arroy gets a lot more rain, and it's one of the only surface areas where rainfall travels on the surface of the island. And so you can be standing up here looking down. So if you look in that picture, you can see it's sunny down below, but it's in a cloud forest almost at the top. So the island generates its own moisture in a lot of ways. The marsh there is a lot like the moai quarry in Rano Kao, where Totora, the sedges, and the polygonum are the primary plants. And there's another picture there of horses. There's more horses and cows there probably than there were people. So there's thousands of animals now moving around the island. Remember, people only live in the town. The rest of the island is a UNESCO site and a national park. But these old volcanic tubes have leftover plants like this hibiscus, which were brought in, considered a royal plant. So we have observations of things that are left now, but the latest uncovering in this Avaranga Uka, this collapsed tube, you can see there right in the middle of this picture is a moai that's laying face down, a single moai, and he's facing north. And then there's a cut bank. So as archaeologists, the Germans wanted to know, did people use Avaranga Uka in the past as a collection water site? In their discovery, you can see here, this is all of us that worked on that. They found 4 phases of plazas that were laid down, and cutting through, you can see the pavements. Avaranga Uka which is the collapsed lava tube coming from Terra Vaca to the coast. In 2014, during our archaeology with the German Archaeological Institute, uncovered a plaza that showed two important things. If you will look where the arrow is, which is yellow, you will see a circular and mini circular forms that were left behind that are roughly 80 centimeters across in diameter. And then over to the right, you'll see a channel for water. So in these plazas, there's multiple timelines of people that were damming Avaranga Uka rainfall and also moving it through these channels. But the location of this timeline with both of these things together, with the water canal and the circular pits, the size of these pits uncovered along with some of the coquito nuts show that the people were actually planting deliberately the giant palm trees, which would have been about 100 years old at this time in that size, near this water canal. So this shows perhaps some of the last efforts to keep these giant palm trees alive. And so this is what a projected view would look like, with the moai standing and the palm trees in their locations of the pits that were uncovered, the dam that you see there off to the right holding water, and the fertility water basin right next to the trees. So a ritual place both for water and fertility of the trees. And so an up-close photo of the basin here, built with slabs. And inside the basin, these petroglyphs were also found. So the you can look down. The first one is a seahorse, or thought to be a seahorse, or some sea creature. So that connection with the ocean and water was really important. And then the footprint and the double-hulled canoe were all found in the bottom of the slab. And then when we look at a cross-section of this basin, you can see the clay layers, the rock layers, the slabs, how it outlined the basin. And then down below in the yellowish white layer was the ceiling layer with the wooden cache, the wooden tools, miniature tools that were left behind. So this basin was very, as we say, representative. And more views, the tree that you see off to the right was at Kew Gardens before they cut that down, and the basin and the palm casts. And the palm nuts that were found in below the basin there. And then another view of the water channel collecting bowls that were carved into the rock. And then the clay layer itself. And then here's some of the cores that I took along Avaranga Uka, looking for palm pollen and trying to determine through dates that the Germans still have undisclosed for Avaranga Uka in this time period. Taking cores into rock streams, very difficult. And then the exciting thing is also happening is that the children are being taught the natural history in school, and they, along with CONAF, are planting thousands of their native plants, the Sephora Toramiro, the Jubaia, the giant palm, and that gives us hope for the future, because these trees take 100 years to flower for the first time. So the children maybe won't see these trees, but they know that they're planting them for the future and the future of the people. And this is another view of CONAF and their due diligence of growing these native plants again to reclaim the landscape. And so I call this hope hope for the future. And this is the video.
So first, if you want to learn more about Candace's work, you can look at a profile of Ronin Institute website. And for the next seminar, it will be about the value of social cohesion in our communities by Angelo Luidens, and it's on February 26th. So don't forget to register if you are interested in. And if you want to see previous seminar or look at what the Ronin Institute disseminated, please follow us on Twitter, Facebook, LinkedIn, YouTube.